Good morning, advanced programming. We are starting a new unit today. We are going to be looking at physics engines. Physics engines are a fabulous software library that you can add to your projects that will take care of all the collisions and physics simulations of how things bounce off of each other, how things react, how things stretch. All the real world physics that you want to have in your game, or whatever project it is you want to create. Lots of games use physics engines and are built upon physics engines. The one we're using is going to be called Fisica. This is the reference page. Fisica itself is actually what's called a wrapper for the Box 2D physics engine. So Fisica, this thing, is not really the physics engine itself. It's just an interface that we can use within processing to work with Box 2D. And I'm really excited about this because Box 2D is a industry standard physics engine. It's really powerful. It's used in lots of games, most notably the billion-dollar empire of Rovio's Angry Birds. So this is a real thing that can enhance our projects immensely, and I'm looking forward to working with you. The first thing you have to do is, download this Fisica example sketch. You can just click it and download it. It comes out as a zip file, and then you can open it. When you first open it, it won't work because you need to install the Fisica library. So I'll just go to my version of this. I already have that installed on my own machine, but I'll just show you how you would go and install that if you needed to. So sketch menu is where you want to start, and just go to import library. You'll see that I already have Fisica installed, but if you don't have it, you can click on add library and then type in Fisica. It's spelled with an F because it's developed in I'm not sure what country, but they speak Spanish wherever Richard Marxer, who is the creator of this library, that's where he lives. So in Fisica, I guess physics is spelled with an F in France. Or no, sorry, Spain, or wherever I'm pretty sure they'll speak a lot of Spanish in France. I think they have their own special language. Blah, blah, blah. Here you go. Now you just click on install, and should just work. It'll take a bit of time, and eventually it'll be good. At worst, you might have to restart processing by the end of it, and you're ready to go to run this Fisica Experiment 1, which we've downloaded from my website. So what is this project? It's really a basic thing that just shows you how to kind of add bodies to the world and how to kind of manage those things. Here it is. This is all it does. It's a bunch of things falling from the sky, and this project seems like it's pretty, I don't know, sophisticated if you were trying to make this yourself. All these collisions, all the bouncing physics, that's a lot of math that's involved. So, that's great, but why reinvent the wheel when existing physics engines already will manage that for you? So what we're going to do is look at this sketch in detail, and then I'm going to tell you about your first assignment, which will just be a little tiny game to practice with using Fisica and Box 2D. So how does all that stuff work? So first of all, even though you've imported the library, and download it and all that stuff, you still have to import Fisica. This is the easiest way to do that, is simply with this statement. It downloads all of the stuff to your sketch you need, and then you need to declare at least this one variable. I have other stuff obviously, but this variable here is very important. Your world variable. It is of type fWorld, and you could take a look on the documentation for more information about fWorld. You won't need to know everything about fWorld today, but it's basically the software embodiment of the world in which all this physics will take place. It's also the manager of all your objects that are in this world. So you're not going to have a list of all these things, at least at first. Later on we'll need to keep a list of certain things, but it'll sort of manage the storing and updating of those things as well. So it's pretty fantastic. In our setup, there's a bunch of things I have in here, but the main one is doing these two lines of code here. This is essential. You must do this to turn on the physics engine in your sketch, and you want to do that as soon as possible. Well, relatively as soon as possible in the setup function. And then here's where we actually instantiate or create the world. And there's parameters you can give this and such, and we'll talk more about that later on. But this is sort of what you need to do to start off. And the world can do all sorts of things. Typical example would be world.setGravity. This is a great example of the power of physics engines. Instead of you going and teaching all of your objects and making a class for each thing and applying some sort of acceleration to the velocity, which applies to the position and all these things, you could just turn on gravity, and all the bodies that you add into this world will then be acted upon by this universal force. So, hey, nice. And you can experiment with these numbers. You can see what happens if you have gravity in the x direction. Maybe your game is, I don't know, somehow like on a slant, or maybe it's upside down, or maybe it's you're walking down a skyscraper and you're Spider-Man and you want to stick to the wall. I don't know what you're doing. You can play with these numbers and see what happens. So in this sketch, I guess the main things I want to show you how to do are make a stationary object like these two ramps, the brown ramps, and also just introduce you to these four, I guess. Really just three types of bodies. The bird one is just F circle, like the red circles, but it has a picture attached to it just to show you how to do that. And then from there, I'll talk about the first assignment. So all this is happening pretty much in, or I guess I should start by saying the platforms or the brown shapes, the ramps, are being created in these two functions. I'll just scroll down and show you how I do that. They're basically the same. I'll look at the top one. So this particular shape is called an F-poly. These are all different kinds of F-bodies. I'll show you an F-circle. We'll look at F-blob, which is my favorite. An F-box is sort of a rectangular one. So all these things are different kinds of bodies. Bodies are things that you add to the physics engine upon which physics is applied. So the differences we'll go over as we look at each one. An F-poly is one where you specify as many vertices as you want. You just give them coordinates, and you can create all sorts of different shapes with an F-poly. You could create a rectangle with an F-poly, or you could create a star shape. You just have to specify the corners of the shape, and it'll make whatever shape you're trying to create. So that is you specifying, or this is me specifying the vertex. Once you've created this F-poly variable, I'm just making a temporary one right now, calling it P. We instantiate it, and then you just plot the vertices. So you just, whatever the name of your F-poly is, and then dot vertex, and then you just say what the x and y coordinates of the vertex are. I'm using some math to do that, so I don't have to think out exactly what coordinate that's going to be. I just multiply it, and that was that. You could just type in a number here, by the way. You don't have to type in some equation. You could type in 200 or whatever number that happens to be. Probably not 200. Here's a couple other things you can do, and you'll notice this is sort of the work that we're going to be doing is sort of learning what all can F bodies do. So it's going to be like the name of the F body, and then a dot, and then some function that you can call. And there's a whole bunch of functions to learn about. This one's a great one, set static. You'll notice that our ramps don't fall when I run this sketch. Those brown ramps are stationary and things bounce off of them. That's because we had those bodies set to static, which means that gravity doesn't pull on them. No force will knock them around. They are anchored to the world and forever will not move. So that's pretty fantastic. You can turn this off by saying F static and then setting the parameter false, and all of a sudden it would start moving again. So you could imagine how you could use that to maybe freeze something in place with a freeze ray or something like that. There's simple things of making them pretty. You can set fill color and then give it a color. Specifically, set fill color requires you to give it a color variable. So you'll notice I've made some color variables up here. I mean, they're color variables in the sense that there's using the color data type, and then whatever name, and then I've just whatever. You could also put in the hashtag, whatever the color happens to be here as well. Like that would be a fine way to define a color. So that's that, and then oops, there we go. Oh, not quite. Yeah. Almost there. Hey, there we go. And also you can do things like set their physical properties. There's many physical properties. We're only going to take a look at one of them. Set friction. And you can play with this. This is setting, how coarse is the surface. And you can play around with setting this to 0 or setting it to, different numbers, and just see how that affects the sketch. You'll probably see that things slide off of the ramps, easier or more difficultly depending on what you set that to. So this is another idea that these bodies we're creating, we're gonna, instead of sort of programming in all the calculations that they need to do, we're just gonna set their physical properties with these functions that will make them behave in different ways depending on their values. So that's 3 examples of properties we're setting. Last but not least, we're going to go back to that world variable again, and the world can add this platform, this ramp. And I just say world.add p, where p was the thing we were creating. Now that's going to be inside of the world, and it'll show up when we start running our sketch if we have the right code in the draw function, and that'll be fantastic. Notice that this variable was declared in this function. I declared it right here, right? I declared it here. And once we leave this function, p no longer exists. It's gone, and you might wonder, well, if it's gone, then how does it, how do we still see it? Well, when we add it to the world, we lose control of p, but the world has a reference to that thing. And we no longer have direct access to it, which is fine because we never want to touch that ramp again. In the future, when we create like a player object or an enemy object or some kind of thing that we want to animate, we will have to store a reference to these permanently. But for now, we don't have to worry about that too much. So that's making a simple platform. I'll also show you the other things. So we could take a look at, for example, there's the bottom platform, basically the same. Here's making an F circle. So this is making those red balls that roll around. So you got, it's called an F circle instead of an F poly, which makes sense because they're circles. This parameter is the radius of the circle. So, depending on what number you send it, you will make bigger or smaller circles. I'm setting the position. So any F body, actually, you can set position, and you can just send it a X coordinate and a Y coordinate. I'm sending it a random number so that they kind of randomly fall from the sky. This is -5, so it's just above the top of the screen. So when we make this circle, it'll be in a random place in terms of its X coordinate, but just above the top of the screen. And then here's some more types of things that we can do in terms of setting the visual properties. I mean, basically they're the same, but notice we can set a stroke. We can set a stroke weight, so we can color things, and we can also set fill. If you look at the documentation, you'll notice that there's set stroke, and then there's set stroke color. They do the same thing, they just expect different parameters. So I use set stroke, and I can give it a number, for example, 0, which is black. And that works. If I tried to do that with set stroke color, you'll get different responses. So remember, if you're using set stroke or set fill, you're going to send it either 1 or 3 numbers, which represents either a shade of gray, or if you send 3 parameters, red, green, and blue. If you're using something like set stroke color or set fill color, you need to send it a color variable. Yeah, I know, it's kind of annoying that they couldn't just have made that work without it, but it's not a big deal. And if you make a mistake, it's not a big deal. Set stroke weight, it's just what you think it is. The line that goes around that shape will just be thicker or thinner depending on what parameter you send it. So that's setting some visuals on my circles. Physical properties, here's some new properties for you to learn. And F-polys have these as well. I'm just kind of spreading it out. So density, You've already seen friction and restitution are some properties. So density is exactly what it sounds like. It's like how how much mass is packed into that shape, and that will affect all sorts of different physical calculations. So how it bounces, how things bounce off of it, all be determined in part by the density of the objects that are colliding. The restitution represents how bouncy these objects are. So feel free to play around with these values. Don't just necessarily keep 0.2. Play around with it. See if you make it different numbers. And the same with restitution. If you make it 0, what happens? If you make it 10, what happens? And just kind of play with different numbers. So again, and you already know what friction is. So that's how rough the outer surface will be. So try out these different properties and see what happens. Add them to the platforms too. See what happens there. Again, the magic of making all this happen, we actually have to add this circle to the world. So world.addCircle is what happens there. This is a function called makeCircle, and I just call this function in the draw function every frame. So I just make circles constantly. You can't just put in void makeCircle. We'll take a look at the draw function a little bit later on. Here's my void make blob. Yes, there are blobs. Those yellow blobs are just kind of form. That's not the right word. Well, they're blobs. watch what it looks like, and you'll find out what it is. Blobs are interesting and can represent various kind of squishy objects. And the idea is that you can choose sort of what their starting shape will be, and I'm setting it as a circle to start with, and we're kind of giving it some possibly interesting properties with that. And again, setting the visuals for their color and stroke weight and all that kind of stuff. The physical properties are similar, except that because it's a blob, you'll notice that it reacts differently. So blobs and circles, obviously a circle has hard boundaries, whereas a blob has soft, malleable boundaries to it. So that'll change how it reacts. So, you might want to model your thing that you're creating in your world on a blob or on a circle. Depends. And again, world.addBlob. That's going to put that into the world. We have a box as well. When you create your box, it's just going to have a width and a height. So this is a rectangular box that is longer or taller, I guess, than it is wide. So you get rectangles. I'm using set position again, falling from the top of the screen, and setting its color and its different physical properties. And then again, adding the box to the world. See the pattern? It's quite formulaic in some ways. You're just going to be, when you kind of create things to add to the world, you do it in this order. Instantiate the object. Possibly set its position and visuals, and also set its physical properties, and then just watch the chaos fly. Last one is make a bird. Bird is just an F circle, as I said before. This time I'm actually attaching an image. This is a P image that I loaded in the setup. So it has to be a valid P image, and all that stuff about loading P images is exactly the same in Fisica. They have slightly different properties, and then I add the bird object, and you'll notice that it has the picture attached to the object, and manages that picture's rotation and everything, because it's effectively glued to that F circle so it can roll around. And this is what we'll do later on to make our our Angry Birds game, or whatever we're gonna make. Well, that's exactly how Angry Birds does it. It just attaches cutesy pictures to F circles and F boxes and F blobs and all that kind of stuff. This is kind of not unlike the code of Angry Birds, so that's pretty cool. All right, so in the end we create this craziness, and I invite you to spend, I'd say, 15 to 20 minutes just modifying the properties of the various objects we have inside of here. I guess there are 5 different objects if you include the platforms, and see what happens with them. And of course, it's just fun to grab a thing and whip it around and smash into things. The physics gets kind of broken because things can't, they kind of overlap with things, and stuff starts breaking that way. If I move so fast, like the blobs get pretty messed up and stuff. But that's okay, because we can limit those things later on. So yeah, enjoy smashing things and that kind of stuff. So just to let you know what the actual project will be, when I get back, we'll start working on that. I'll show you one of a version of Dax's from last year. I don't know if you know Dax. He's in grade 12. Good old Dax, always handing in great projects. It says Pong, but we're not going to call it Pong this year. We're going to call it table hockey, I guess, or what is that? What it's called? Air hockey. Yeah, air hockey. We're gonna change it to be a little bit different than last year. So basically, the game is a simple sort of. It's very noisy. It's a simple game of pong or air hockey, and you're gonna create this whole world in Physica. All the collisions, everything's gonna be managed by Physica. So mostly, you just need to have your objects added. I forget how to. He's got some way of whacking. Oh, there we go. You sort of like. Ooh, that was interesting. You can whack the ball by rotating your paddle. We'll probably make circular paddles as opposed to rectangular paddles because as you can see, the whacking didn't turn out so good. We'll have some kind of way of keeping score. I'll just go and like dump this into my own net because I suck at this game. And you can see that it keeps track of the various points that people like. Mostly, this exercise will be one for just practicing Physica. Okay, so thank you very much, and we'll hope you have a good class.